This is lesson 4-9A from the Algebra Readiness textbook. For today's lesson, you will want your chapter 4 notes packet, a sharpened pencil, and to have completed the study guide questions. When you're ready to compare your answers to mine, continue the video. Simplify a to the 7th and divided by a to the 5th. We learned that when you have the same base, you can subtract the exponents, which gives me a to the 2nd power. The next one, simplify 2 to the 4th, m to the 6th, all over 2m to the 5th. Well, we know that 2 is really 2 to the 1st. So let's break this down and start with simplifying the numbers. So they have the same base of 2. So 2, and then I subtract the exponents. 4 minus 1 is 3, 2 to the 3rd. Then let's look at this, the variables raised to a power. They have a common base of m, so I subtract the exponents. 6 minus 5 is 1. I can simplify this even further by saying 2 to the 3rd is 8, and m to the 1st is the same as m. So in simplest form, I would say 8m. Today's learning target is to convert standard and scientific notation. In your notes, write down the definition of scientific notation. Scientific notation is an efficient way to write numbers that are very large or very small, using powers of 10. This is an example. This number that you see is very, very large. It's much more efficient to write it in scientific notation. 7.5 times 10 to the 12th power is scientific notation. Notice that the first number, 7.5, is greater than or equal to 1, but less than 10. And that's going to be true of all numbers in scientific notation. This first factor needs to be between 1 and 10. Now, the second factor is always 10 raised to some power. That is how you get all of these zeros. Let's explore scientific notation. You have this chart in your notes. Fill it out with me. 5 times 10 to the 4th. Well, you know that 10 to the 4th is the same as a 1 with 4 zeros, or 10,000. So 5 times 10,000 is the same as 5 times 10 to the 4th. 5 times 10,000 is 50,000. 5 times 10 to the 3rd. Well, 10 to the 3rd is the same as 1 with 3 zeros, or 1,000. 5 times 1,000. And 5 times 1,000 is the same as 5,000. Now, while we're exploring this, what I want you to be watching for is how do I go from scientific notation to standard form in this column, and by skipping the middle column. What's the shortcut? What's the pattern? How do I go from 5 times 10 to the 3rd to 5,000 without showing the work in the middle? So let's keep going with our pattern. 5 times 10 to the 2nd is the same as 5 times 100, or 500. 5 times 10 to the 1st, well, 10 to the 1st is the same as 10, and I get 50. I'm going to give you another hint about this pattern. Some of you are watching, and looking and not seeing. Some of you have already figured it out. It has something to do with the exponent and the location of the decimal. 5 times 10 to the 0 power, well, 10 to the 0 power is 1. 5 times 1 is 5. 5 times 10 to the negative 1 is 5 times 5 times 1/10, which is the same as 0.5. 5 times 10 to the negative 2 is like 1 over 100. Here it's 1 over 1,000. Here it's 1 over 10,000. And so what we end up with is, all right, 1,000th and 1/10,000th. All right, hopefully you see that the exponent, let's use the first one, of 4 moves the decimal point of the 5. So there was a 5. The decimal follows it. It moves it 4 places to the right. And I get 50,000. And if my exponent is negative, it moved my decimal to the left, the same number of places as the exponent indicates. In this case, 1. So my answer is 5/10. Let's do this question. Based on the pattern you see, simplify 5 times 10 to the 7th. 5 times 10 to the 7th, I start with the 5. Because the exponent is 7 and it's positive, I'm going to move it to the right 7 places. I'm going to use zeros as my placeholders, and my answer looks like that. 50 million. All right, let's put this in more concrete words. 4,200,000 people visit the Statue of Liberty each year. Write the number in scientific notation. Let's remember that the first number has to be between 1 and 10. So the first thing you need to do is place the decimal. So that you have a number between 1 and 10. In this case, between the 4 and the 2. Now, the second thing you're going to do is count the number of places to move the decimal back where it belongs. Let's try that. If I move it here between the 4 and the 2, to put it where it belongs, which is at the end, 1, 2, 3, 4, 5, 6 places to the right, times 10 to the 6th. If it's to the right, you have a positive exponent. If you move the decimal to the left, that's a negative exponent. So 4,200,000 written in scientific notation is 4 2/10 times 10 to the 6th. Let's try one more. Write the following in scientific notation. 54,500,000. The first number needs to be between 1 and 10. Where should I place a decimal so that so that I get a number between 1 and 10? It's always after the first digit, always. So it's going to go between the 5 and the 4. 5 and 45/100ths. Now I multiply it by a power of 10. To figure out what exponent should be in there, I figure out how many places I need to move the decimal point to get it back where it belongs. And in this case, it's 7. Since I have to move it to the right to get it back where it belongs, it's a positive 7. Big numbers always have a positive exponent, and little numbers always have a negative exponent. Pause the video and try question B, 723,000, writing it in scientific notation. Come on back to compare your answer to mine. I've decided to put the decimal between the 7 and the 2 to get a digit between 1 and 10. Then I multiply it by a power of 10. I raise it to the 5th power positive 5, because number one, it's a big number. Number two, I had to move to the right to get the decimal back where it belonged, and it was a total of 5 places. All right, let's try some that are super small numbers. In this case, I have 0.000079. It's easier to write that in scientific notation. Again, right after the first non-zero digit, 7.9 is where you're going to place the decimal, times 10. Now, we have to raise it to a power. The exponent is where do I move, or how many places do I move the decimal to get it back where it belongs? 1, 2, 3, 4, 5 places. But I move it 5 to the left, so I put it as a negative exponent. Okay? All right, pause the video and try these two. Come on back to compare your answers to mine. To get a number between 1 and 10, I need to place the decimal between the 2 and the 1. I multiply it by a power of 10. 1, 2, 3, 4. To get the decimal back where it belongs, I need to move it 4 places and to the left, so it's a negative 4. In this one, I would have to put the decimal after the 5. 5 times 10. The exponent, 1, 2, 3, 4, 5, 6, 7, 8, is 10 to the negative 8th power. Now, standard notation is the same definition in scientific notation as it is in exponential form. When we're dealing with exponents, we define standard notation as the usual form of representing a number. The same is true for standard notation. In scientific notation, these are given to us in scientific notation. We want to write it in standard notation or standard form. We're going to work with the first number, 8 and 9/10. Then I look at my exponent. The exponent is a positive 5. Positive equals move the decimal to the right. Negative exponent, move the decimal left. And the actual number 5 is how many places to move it. So let's give it a try. I'm going to move my decimal 5 places right. 1, 2, 3, 4, 5. That's where I'm going to put my decimal, back where it belongs. I use zeros to fill it in. A common mistake students make is they want to just add 5 zeros to the end of 8.9. That's not right. That's not the number of zeros. That's the number of places to move the decimal point. Then we need to add our commas in where they belong. 890,000. Letter B, let's try this one. I start with 2 and 71/100ths. My exponent tells me to move the decimal to the left 6. It's currently here, 1, 2, 3, 4, 5, 6. Then I use zeros to fill in the missing place values. And this is my number right here. And then that decimal goes away. This is my answer. All right, pause the video, try these 3. Come on back to compare your answers to mine. Okay, I see that this exponent tells me to move the decimal 7 places right. 3, 4, 5, 6, 7. And then I add my commas in, and I get 32,100,000. Letter B, this exponent tells me to move the decimal 8 places left. Then I fill in with zeros, and this is my answer. Oops, that decimal goes away. All right, then letter C. I need to move my decimal 10 places to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And fill in with zeros and commas. So 10 billion, 60 million. Now, for a number to be in scientific notation, the digit in the front of the decimal must be 1 or between 1 and 10. Now, sometimes we'll get a number that appears to be in scientific notation, but not really. And the reason it's not really is because the first number is not between 1 and 10. So, that requires me to move the decimal point, doesn't it? The decimal should actually be, let's erase this, that decimal should actually be between the 3 and the 7. So that would be moving the decimal one place to the right. So that should be 3 7/10. Now, I no longer need to move the decimal. Remember what the directions tell me. That means move the decimal to the right 10 if the decimal was before the 3. But when I move the decimal one place to the right, I no longer need to move it a full 10 places because I already moved it one of those places. I need to move it 9 places to the right. Okay? I'm going to say that one more time because some kids have a hard time with that. Most kids understand that the decimal point needs to be right here, between the 3 and the 7. The current way that the number is written, with the decimal before the 3, the exponent says, move the decimal 10 places to the right. Those directions no longer work if I place the decimal point between the 3 and the 7. I need to compensate for moving the decimal one place to the right by renaming that exponent with a 9 because I already moved the decimal one of those 10 places when I scooched it over 1. Let's try letter B. The way this is currently written, my decimal is in the wrong place and my exponent says move it 8 places right to get the decimal in the proper location. However, the decimal actually belongs here, which is between the 4 and the 5, 4.531. Now remember, the way it was originally written, from here, I need to move it 8 places to the right. So how many places to the right do I need to move it if the decimal is supposed to be between the 4 and the 5? Hopefully you see that that's an additional 2 places. So my exponent needs to be 10 to the 10th. In proper notation, it would be this. Okay? For those of you that might be having trouble with this, I want to illustrate this one more time. 453.1 times 10 to the 8th means 453.1, and I need to move it 8 places. 1, 2, 3, 4, 5, 6, 7, 8. Oops, I just wrote an 8. Sorry about that. Do you see how I moved it 8 places? Now, what I am telling you is that the decimal should be between the 4 and the 5. Now, if it's here, I have to move it an additional 1, 2 places, and all of the others, all the other 8. So a total of 10 hops. Do you see that? These 8 plus 2 more equals 10 places. That's how I got that that exponent of 10. Pause the video and try these 3, then come on back to compare your answer to mine. For the first one, I know the decimal is currently here. And when it's here at the end, I need to move the decimal 5 places. To get it where it belongs. But I know that in proper scientific notation, that decimal should be between the 1 and the 6. Now, I no longer need to only move it 5 places, I also need to move it 1 more. So instead of it being to the 5th power, it should be to the 6th power. Letter B. From where the decimal currently stands, I'm supposed to move the decimal point 6 places to the right. This is not in proper scientific notation. I know that because this first number here is not a number between 1 and 10. The decimal, however, when I look at it, should be right here. 2.03 times 10. So I don't need to, if I put the decimal where it belongs, I actually need to move it 1 place fewer because I'm not moving that 1 place right here. So it's 10 to the 5th power. When I scooch the decimal over 1, I already did one of the places. Letter C. The decimal currently is at the end. 7243. And it wants me to move it 12 places to the right and fill in all of those zeros. Okay? But I know that in proper scientific notation, the decimal point should be where the comma is. That makes a number between 1 and 10. That means that if I'm going to move my decimal point, I don't just move it 12 places. It was 12 places from here. So from where the decimal should go, do you see it's an additional 3 hops? So if it was right here, that's an additional 1, 2, 3 hops plus the 12 hops from before. A total of 15 places to the right. All right, we're going to give some homework a try. Your homework for tonight is page 214, numbers 6 through 22. Give those a try and make sure you see me on Google Meet if you need it or need something to go or need to go if you need to go over any of the problems together. Have a good day.